Ever wondered how battery cells are made? These tiny powerhouses fuel our world, from the smartphone in your pocket to the electric car in your driveway. They're everywhere and integral to our modern life. But have you ever stopped to think about the process that brings these energy marvels to life? It's a journey that combines science, technology, and a dash of magic. So, buckle up and hold on to your seats as we delve into the mesmerizing world of battery cell production. It all begins with understanding the basic components. A battery cell, in its simplest form, consists of three major parts: the cathode, the anode, and the electrolyte. The cathode, often referred to as the positive terminal, is where the energy is released when the battery is connected to a device. It's the heart of the power supply. Next, we have the anode, or the negative terminal. It's the part that donates or loses electrons to the cathode through a chemical reaction, causing an electric current to flow. Last but not least, the electrolyte. This isn't just a fancy term, it's a crucial part of the battery cell. It acts as a medium, allowing the flow of electric charge between the cathode and anode. It's the facilitator of the energy transfer that powers our devices. With these three significant components, we're ready to start the battery cell production process. The first step in our process is the preparation of the electrode. Now this is where the magic begins, folks. Two types of electrodes are involved in making a battery cell: the anode and the cathode. For the anode, we primarily use graphite. Why graphite, you ask? Simply put, it has an excellent energy storing capacity and makes for an ideal choice. On the other hand, the cathode is where we bring in lithium. Lithium is a lightweight element with a high electrochemical potential. This means it can store a lot of energy, making it the perfect material for our cathode. The preparation process involves coating thin sheets of metal with these materials, ensuring an even spread for optimal performance. The sheets are then dried and compressed. This is a delicate process, requiring meticulous attention to detail and precision. With the electrodes prepared, we're halfway through our journey. Stay tuned for the next part of our battery cell production process. Now it's time to bring the electrolyte into play. This is the secret sauce that makes our battery cell come alive. The electrolyte, often liquid in nature, serves as the highway for our ions. It allows them to move from the anode to the cathode when discharging, and vice versa when charging. But how do we introduce this crucial component into our battery cell? Well, it's a delicate process. We first soak the cell in the electrolyte, allowing it to seep into every nook and cranny. It's like marinating a steak, but instead of adding flavor, we're adding the ability to store and release energy. Once our cell is thoroughly marinated in the electrolyte, it's time for the assembly process. This is where we bring together the anode, cathode, and electrolyte, our three key players. We place the anode and cathode into a special casing, with a separator in between. This separator prevents short circuits while still allowing ions to pass through. Then, we add the electrolyte-soaked cell into this casing. This assembly process is a meticulous task, and it's done under precise conditions to prevent any contamination that could affect the performance of the battery cell. It's a bit like performing a surgery where every move is calculated and every precaution is taken. With all components assembled, we're on the verge of having a complete battery cell. The final steps involve sealing and rigorous quality checks. Once the battery cell is assembled, it's sealed off to prevent any leakage of electrolytes. This sealing process is meticulous and precise, ensuring the longevity of the battery. But we're not done yet. The battery cell now has to prove itself in the arena of quality control. Quality control is the gatekeeper, ensuring only the best make it to your devices. Voltage checks are performed to verify the cell's electrical output. This ensures it can power your device as expected. Then we run leak detection tests. Even the smallest leak can compromise the battery's performance and safety, so this step is crucial. Moreover, these tests aren't a one-time affair. They're periodically repeated, even after the battery cell has left the production facility. This way, we can guarantee that the battery cell you receive is top-notch, all the time, every time. And there you have it, a fully formed and ready-to-use battery cell. From humble beginnings to powering our world, the journey of a battery cell is truly fascinating. We've traced the life of a battery cell from its inception, understanding its basic components, through the meticulous production process, and finally, finishing and quality control. It's a complex dance of science and technology that powers our devices, cars, and even our homes. Until next time, keep those gears of curiosity turning. And remember, there's always more to learn in the world